Okay. Right. Well, what we are doing here is refactoring. What we want to talk, what we really want to talk, is about refactoring. So I will start with the little definition of refactoring. I will bore you a little with that, but what I want to make emphasis is that what we want to do when we do a refactoring is to change the structure of the code, but without changing its behavior. We have to be sure that we don't change the behavior. We have to be sure about that. So, because we have perhaps working code, that would be the case, the theoretical case, that we have working code, and we need to improve it, but, well, we want to continue working just like it does. So, we do refactorings all the time, and many of them are similar. They're cataloged in, for example, here's a catalog of refactoring patterns. So we need tools to avoid doing them manually. Why do we want to? We don't want to change our code manually because it is error-prone. If you have working code and you change it by your hands, it's probably that you make a mistake, and it's a boring task. You have to extract the method or change the name of a variable. Those are boring tasks. You don't want to do that. So you need refactoring tools. We have many refactoring tools. I will speak today about a specific refactoring tool we're working on that intends to migrate an inheritance relationship into a delegation relationship. So it's not a new refactoring, but I think it's not that easy that you might think at the first sight. So I will try to convince you that it's really complex. Well, here this is a word that might be explained. Why you say semi-automatic tools and not fully automatic tools? So why semi-automatic? The thing is, I don't want to lose the control of my code. I don't trust them. Well, I trust them, but I need to see what is going on, and I want to know what would be the result of the refactoring. And even more when we start doing more and more complex refactorings, you have to be able to be sure that what the tool is going to do is the exact same thing you want. So I think of a refactoring in 4 steps. The first step is to identify the need for a refactoring or the opportunity to make your code better by a refactoring. Then you have to analyze the impact the refactoring will have. And then you have to take a decision if you like to do the refactoring or not. And last, when you are sure that you want to do that, you perform the refactoring. I think I divide this way because I think the steps 2 and 4, they can be automatic. They should be automatic. You don't want to change the code manually, and you want tools to help you analyze the impact of your refactoring. The step 3 shouldn't be automatic. That's what you, as a programmer, should see the code and should be sure that you are performing a good refactoring. The step 1 is the most complicated because, well, I think we should build tools to help you identifying refactoring opportunities. But, well, as I tell you later, that's work in progress. We haven't done many on the first step. So we will focus today on the steps 2 and 4. Our example is the Faro dictionary. I think this program is in most Smalltalks or in every one. Well, it's also in the ANSI Smalltalk standard. The dictionary, well, the hashes collection is particular from Faro, I think. But the thing is that in dictionary you have cancel methods, you have many problems that it could be solved if you avoid extending dictionary from collection or hashing collection. That's an implementation of hashing collection. There are many problems with this decision, so it could be possible to solve some of these problems if you avoid the inheritance relationship between these two classes. But changing the hierarchy is very complex because, for example, you have here, let me remember the example. You here have the active absent method in dictionary, which sends the find element of nil message to self, which is not implemented in dictionary but in hash collection. So you have a dependency between the code in dictionary and the code in hash collection. That's normal, it's not a surprise for us. But it is a dependency, and you will have to see how you change the code to be able to take the inheritance away. And you have also a dependency in the other way, because find element of nil sends the message scan for itself, which is abstract here, I think. I'm not sure if it is abstract right now, but for sure it's overridden in dictionary. So when you send the scan for message from hash collection, you will be executing the code in dictionary. So you have dependencies both ways. What we would like to do is what already Martin Fowler explains in his book. It's not a new refactoring, it's what he explained. It's to change the inheritance for a delegation. So the new dictionary class will be a direct set class of object, and it will have a delegate variable that will point to a hash collection. And whenever we had code that invoked directly code from hash collection, you would change the self receiver you had created and change it for delegate. So you delegate all the methods into the hash collection. And if you had methods in hash collection that are not overridden in dictionary, perhaps you should add what we call a delegating method. What is this? The dictionary implements a method with the same name that as in hash collection, and what it only does is to resend the message to the delegate. It does nothing but resend the message. This is the refactor as is explained by Fowler. But I think there are many problems that are not explained in this strategy. So, for example, we have here more methods in the relation hierarchy. I'll explain some of them quickly because it would take a lot of time otherwise. So we have not only self-sense but supersense. We have abstract methods. We have abstract superclasses. In fact, hash collection is an abstract superclass, so it won't be possible to have an instance of a hash collection here. You have also in front of you have undefined methods. For example, here the method step in the class object sends the message step, which is not implemented anywhere in the hierarchy. So if a dictionary receives this message, it will break. You also have the cancel method, which already I talked about. And what no one in the Java world takes care about is the object methods. Because in Java, the object class has only 8 methods or something like that, and they're very simple. It's a very small class, which gives nothing to you. But in Smalltalk, the object class has something like, in Faro there are 300 methods, and they send messages to each other. So it's not easy. And if you can see here, the method print on, full print string in object sends the message print on, which is overridden in collection, which calls print name on, which calls super print on. So the dependencies is quite complicated. It's not easy to see the dependency with those methods. And also we have open recursion, which I will explain later in more detail. So these are the problems we want to solve. Okay. What do we expect from our solution? Well, the first two I already said. We want automatic dependency analysis, we want automatic code transformation, we want the user to see the proposals and make decisions, change perhaps the code, whatever it wants to do. And this is more important, we want limited impact. We want to be sure that our refactoring doesn't change the system behavior. And our strategy to do that is to minimize the modification outside what we call the target class. In the example, the target class will be dictionary. This is the class that we want to remove from its hierarchy. And the final implementation should be polymorphic with the original one. The final implementation should be polymorphic with the original one. Why is that? Because if it's polymorphic, then a potential user, a client of the dictionary class, will be able to use either of the two implementations without making changes itself in his code. So it's transparent for him and allows us to have limited impact. Also, we would like to have language independence because we don't want to make a tool only for Faro, but it should work in several languages. So, but does it not easy because of the type systems? That means we here said I want to be polymorphic, and polymorphism will be different if you are in smalltalk or you are in Java, because in Java you will have an explicit common subtype between the two implementations, and you should look for that subtype. So we will focus for us in object-oriented, class-based, dynamically typed languages with simple inheritance. That's not so wide as I would like to, but it's our first step to go there. Well, our strategy is divided in 3 phases. The first one is the most interesting, I think, the analysis phase that will be giving us information about the dependencies between the classes and the hierarchy we want to change. The second one is the code modification phase. I will explain this more deeply in the next slide. The second one is pretty much straightforward. Once you have the dependencies correctly analyzed, changing the code is pretty much trivial. It's not a problem. It's only a technical difficulty to manage the code. And after that, I will talk about some additional corrections we want to make that are not easy in the initial implementation proposed by folks. So, our analysis phase has 3 big important points. We want to see which are the methods that can be invoked when you send a message to the dictionary class. Then we compute the dependencies, and we have to decide which will be the final interface for the class after the refactoring. The first step is to compute the invocable methods. That means the methods that can be invoked every time you send a message to dictionary, a method in the hierarchy will be invoked. But some of the methods that are defined in collection or object would never be called because they are overridden. So we don't take them into account. So the first detect some messages, like I told you about step and step in, which are not implemented anywhere. And when we rule this method out, we should also see if these messages that we have taken away, they are sent anywhere in the hierarchy, and then this method also we have to remove them. So we repeat this step until we found no more methods. And hopefully, there are still methods that won't be removed after doing so. I have tested with the dictionary and it works. We don't remove all the methods. In 2 rounds, we found all the problems. So here are some examples that are removed here. Stepping, as I told you, sends the step message that is not implemented anywhere, so it should be removed. Removal sends the remove message that is cancelled, so it should be removed. And remove method is cancelled, so also it's removed. And now we go into the most important part that is the dependency analysis. For that, I think, well, I'll start with the instance variables. If we are working in parallel, instance variables are accessible for the subclasses, but when we break the inheritance relationship, they won't be available anymore. So the easiest way to go is to replace each instance variable access for an accessor. What happens if we don't have the accessor available for us in the subclass? So we have a problem that will be explained in the last part. Perhaps we should change the superclass. That's what we didn't want to do, but in some cases it's not possible. But the most important part, the most interesting part is about the method sense. So for that we have divided the code in 3 parts. The first part, the first group of code is the own code. It's the code that is contained in the dictionary class itself. And then we have the inherited code that are the methods, the code that comes from the superclasses below object. In this case, it would be the hash collection class and the collection class. And the last group would be the object code. That in Pharo is not it's not only the object class but also the product object class. So we have to take care of all of these classes, object and potentially all of its superclasses. And once divided the code in that way, we would look for every self-message, self-send, or super-send in all of these methods in all of the computed the code that we computed in the first step, and we look for each message. We want to see if the place where the message is sent is placed in the same group as the method that will be invoked by this message send. Why is that? Because we're going to change the hierarchy. So if you have a message send in dictionary that invokes code in one of these 2 classes, it will change its behavior if you remove the inheritance and you make it inherit directly from object. So these are the dependencies that we should be aware and we should care about them. Why do we take the object dependencies in a different group? Because dictionary will be a subclass of objects, so this code will be available. This is the code that won't be available, and this is the code that we want to access by the delegate we will have. How much time? Okay. Perhaps it's worth saying that when we are talking about self and super messages, we always are able to compute exactly which method will be called when the message is sent. Because if I send a message to a variable, to an instant variable, or to a parameter I receive, I don't know which class the object will be, and I don't know which method will be invoked by the message sent. But with a self message and a super message, if I know that the object I am analyzing is a dictionary object, so I can compute the invoked method accurately, without problems. So here we have some examples of an intergroup message sent in the dictionary hierarchy. Let's see. Some of them we have already seen. The active absent method here sends the find element of nil, that active absent is in the own group, and find element of nil is in the inherited group. And here we can scan for, which is placed in the inherited group, and it sends a message that it will be implemented in the dictionary in the own group. And the same happens here with print on, because print on is sent from old print string, and this is in the offset code, and the method is overridden here in collection, which is in the inherited code. So this is a dependency we have to take care of too. The last step of the analysis would be to compute the final interface of the system, of the dictionary class. This can be done in several ways, and also it depends on the type system of the language you have. We are working in a dynamic language. We choose to work in dynamic languages for now, so we take the easier path, which is to take every message into dictionary. Every message that is in hash collection or in collection, and is not private, not marked as private in the private category, and it is not overridden, or it wasn't ruled out by our program detection algorithm, we will include it into the final inheritance, into the final interface. I will talk later about how this could be done in Java or in a statically detected language, if I have time. So, once we do that, we can perform the modifications, adjust the class to the decided final interface, and eliminate the descriptive method, add the delegating methods, and modify invocation to the inheritance code. Every sub% have to be changed every time we find the word supper in dictionary. We change it for delegate. So every method that was sent to the supper pseudo variable will be sent to the delegate variable now. And the substance of the inheritance methods that are not included in the final interface also have to change it by the delegate. We do not have to change all of the substance because many of them will be included in the previous step as delegating methods. So we can avoid to make more changes because the delegation will be done indirectly into the delegate. So we avoid modifying that. But the support have to be changed every time. Okay. As I said before, this is pretty much easy. What does have problems for us is the open recursion. So this is the last phrase of our algorithm. And this is what can be made in this class diagram. We will have to change it. Why is it that? Well, what is open recursion? We already have seen some examples of open recursion here. And it is used mostly in object-oriented programs, perhaps to implement template methods. What does it mean? That I have code in the superclass that sends a message that is overridden in the subclass, so it allows to the more general code in the superclass to invoke code that is redefined or defined only in the subclass. An example of that we have here, we have the all-satisfy method that is implemented using do. But do is not implemented in collection, it is abstract in collection. So it would call the method do implemented in some subclass. In this case, do is implemented in dictionary. So the problem here is that the communication in the inheritance relationship between collection or hash collection and dictionary is bidirectional. You can have code from dictionary to sending messages to or invoking methods in collection and hash collection, and you can have methods in collection and hash collection that send messages and invoke code in the dictionary class. So here you see this reference is only in one direction. You can only have messages sent from here to here, but not the other way around. So we have to provide some strategy to allow the communication to be bidirectional. Well, this is not easy to achieve without inheritance. In some languages like self, when you delegate a message, you can do this because it has a special delegation mechanism that when a message looks up its way to the parent self, the self object here, the self object, it's also delegated. So it's a bit more complex delegation mechanism. It's not the simple delegation that we have in class-based object-oriented system. But, well, as I said before, we want to be able to perform this modification in class-based object-oriented languages, so it's not common to have such kind of delegation. So what we do is, it's not, this is either an idea of mine. It's seen in the work of Kegel. He worked in Java and he makes that. So we take his idea and we adapt it to our needs. The idea is to create a user class of hash collection. It will be placed in the same place as the dictionary before, and add an instance variable to this new class to the dictionary. So the two objects, the dictionary and the new class instance, will know each other and will be able to send messages either way. And we have what we call inverse delegation. So we can override methods from hash collection and delegate them into the dictionary as needed. So we can make the communication bidirectional. So this would be the final implementation of our algorithm. The final status after the refactoring of the code. We add the new class called dictionary delegate, and for each message, for each method that is called from hash collection to dictionary, we override it in dictionary delegate, and we perform an inverse delegation. We delegate to the dictionary. So you can see now that the dictionary knows the delegate and the delegate knows the original dictionary. So they can communicate both ways. I think you will think when you see that it's more complex than the original definition. So we have to explain why do we do that. I'm comfortable. But you put the inheritance back again. You said you wanted to take the inheritance away and you already get it back. So is it worth it? Well, perhaps not. That's what we want to think about it now. The inheritance, the new inheritance here, the dictionary delegate solves three problems. The first one I've already talked about, the open recursion, the replace methods, they are all solved by the new class. Secondly, if we had a direct access to an instance variable of hash collection or collection in dictionary, which we had, we could, and we didn't have an accessor to that variable to make a simple change, then we can add the accessor in the new delegate class. So it can solve that problem too. And also, if hash collection would be an abstract class, well, the delegate would be concrete, so you have that problem no more. Also, our refactored solution has several advantages. On the first place, we remove what we think unsound inheritance, because dictionary is not really a hash collection. They don't respect the least cost substitution principle. You cannot use a dictionary where you were using a hash collection. It is not a collection. It is something different. So I think the dictionary extends the collection class only for implementation purposes, to reuse its implementation code, but it works differently. You cannot add or remove objects directly into a dictionary. You don't want to do that. You add it by a key. So that's why the add and remove methods have to be constant. It's not casual. It's because the inheritance is wrong. So we also were able to clean the dictionary interface with more flexibility, because the classes now can be combined but anyway. So when you have an inheritance relationship, dictionary can only extend one class. But if you have a delegate, if you have a variable, you can change the receiver and you can combine the classes differently. More flexible solution. On the other side, we have explicit dependencies, which can be here. It's every message that is sent to the delegate variable is an explicit dependency between these two hierarchies, and every message here sent to the dictionary is an explicit dependency. The dependencies are more clear now. And I think that if you don't like the new subclass, you could think this as the first step of a bigger refactor. Once you have more flexibility, you have more clear interfaces, this could be a first step to perform more refactors. So I don't propose to leave the code like that. It's just a first step. You remove the inheritance. Now you have to think what to do with this. Or, you have more possibilities. Because, as I said before, the most important part of this is the analysis phase. That will make the dependencies explicit. You can handle those dependencies. So, the dependency analysis will tell you if you need the delegate subclass or if you don't. If the analysis says you don't need the delegate subclass, well, you can perform the analysis easily. If it says you do need, well, perhaps you decide not to do the refactor. Or you can say, well, the superclass may need modifications. I will do it, and the model will be simplified. Or also, this is very important for me, the reverse delegate is an object that I feel that it's missing. Perhaps when you see that object, you can find a meaning for it. That won't be done by the algorithm itself. The algorithm only moves methods. If the object, the new class has semantic meaning, you have to find it by yourself. And that's another reason, because the method cannot be fully automatic. That has to be done by a human being. To see the code that you have there, the dependency they have, oh yes, that means something to me. I think that it has happened during the test. It has happened quite a few times. Also, if you see the dictionary delegate, the code that is in there, I think it could be a real, it could have a meaning for you. Well, another possibility is to I mean, the strategy should be language independent, but when you are solving a problem, you are working in a specific language. So perhaps you, in that specific situation, you can use specific tools for your specific problem. Perhaps the phrase would be an example. So perhaps the dictionary problem can be solved by using phrase with another strategy. And perhaps you need to discard the modification of something else. So we are getting into the conclusions here. The problems we solve is the dependency analysis. Without reverse delegation, we are already able to remove abstract methods, concept methods, notifying methods, dependencies from own code to the inherited code, and it's fully transparent to clients. With the reverse delegation, we also could solve 3 more problems that are the same that I told before: the dependencies from the inherited code to the own code, the variables access, and the abstract subclasses. Well, I think the discussion, why not fully automatic, I think I've already covered it. So our objective now is to be able to choose the target class automatically. Not automatically. The tool should be able to propose possible target classes. The decision goes on always to the program. Validate change before execution, and also it would be nice to decide the refactory class interface. So in this case, I took all the methods from the support class into the new class, and I think it would be a good tool to allow the user to decide, well, I want this one and this one and this one, and so many of the methods don't make sense. If you see the refactory dictionary in our example, it will have already methods that make no sense for a dictionary. Methods that we cannot detect automatically, or at least we couldn't yet, because they semantically are wrong for a dictionary, but if you execute them, they work. Perhaps they break the dictionary, but they wouldn't produce an error. So they are more subtle problems that we cannot solve automatically. And another nice consequence is that the superclass after the refactoring doesn't have to be object. So we started still thinking about the refactoring and making the dictionary as a class of object. But I also could take any other superclass in the original hierarchy and move dictionary as a class of class. And the refactoring works quite well. Some related work, well, I mentioned microcontroller a bunch of times, so it has good ideas, I think, but it does not define an algorithm. It's only a guide to do that manually, and I think we shouldn't do this manually. And it ignores a lot of the non-trivial problems. And the other one, the most similar work to this one is the Kegel and Schleiman work, but it's made in Java, and also there are many problems that we find here that they don't care about, like the object methods, the cancel methods. The open recursion solution is similar to us, but he uses inner classes. Well, he works on a statically typed language, so the decision of the final interface and the problem of making the final solution polymorphic with the original one is solved in a quite different way. Finally, our future work. Now I'm working in integrating this into Move, not the refactoring thing, but the analysis phase. Can be visualized in a monkey renderer, and well, you can navigate them using the Move browser. We want to perform a deeper analysis of the dependencies on the object code and the inherited code. I think I quite have them, but I have to do some tests yet. Well, I want to consider more inheritance schemes, traits, exist, multiple inheritance. That means perhaps we wouldn't like to make a solution dependent that depends on using traits in the final solution, but we should be clear about if the initial solution uses traits, which can be possible if you're working in parallel. So this is not taken into account. I already talked about detecting candidate targets, and well, the typing problem is also a very nice place to play around to decide which would the messages that the final implementation should implement. So that would be it. Questions?
I can understand how you are assuring that the behavior is not modified as the application of the refactoring. Are you using some form of increment method or unchecking something like that?
No, I'm not using anything like that. It should be in the full work. I do not know why it is in this case. It is something we would like to do in the next month. But what I do to be sure of that intuitively is that the dictionary interface is not modified. So anyone that uses a dictionary now will be able to use the dictionary after the refactoring. The modification, the interface doesn't change. We only remove some methods that they do not work, so if someone was sending them, it had a problem already. And we want to make sure that every message sent ends at the end invokes the same code as the original implementation. That's what we try to be sure about, and I think it's done. So I need to get a formal approval of that, but I'm pretty sure that it works.
I didn't understand what to do with the super cars and what to replace them. Also, how to deal with something like this kind of
The is kind of is a problem we have to care about, and also not also the instance of, but also it should be in the work too. Sorry, but also if one method here returns self or something like that, it could be that the caller sends other messages to the dictionary that we are not taking care of. So this is working. And the first question was the supper.
Suppose if you have a supper calling a method in object, it's not a problem. But if you have a chain of supper calls, how do you replace that in the final code, structured code?
If you have supper calls here, it's not a problem because this inherited chain is not broken. If you have a subgroup code here, it will be changed to a code to the end. So it shouldn't be a problem. The problem is, and that is why I want to study the dependencies within the object code and inherited code more deeply, is that you could have a subgroup call or a self call here that ends invoking that delegates hash collection. I think you should be seeing that. If you have a delegate here, and the delegate calls a method here, and it calls another method that could be invoked code here. And the code here, if it sends a message like do, that is variant it would happen in this example. Let me use it. If it sends do, in the original implementation, the call from here to the method do would invoke this do, but in the final implementation, if you did that path, it would be invoking this do here. So that's the problem. When you have a long message chain that crosses the variables through the three groups, that's the problem. I think I have a solution for that, but I couldn't implement it.
One more question?
In this example, we have a dictionary that was a single class and we inherited from hash collection. But what if you have another situation where you have several classes inheriting from the same class, and you take one of the subclasses as a target class for the refactoring? What happens to the other subclasses? Do you have an idea of to consider
the subclasses of dictionary? If the dictionary has subclasses, they will be taken into account. It's not a problem. They are also considered on code, and it works. This is one of the last things I added, so I have to analyze multiply, but so far I think it has no problem. And if hash collection has another subclasses, I think they don't have problem with it because I didn't change this yet. So if hash collection has another subclass, it won't be affected by the change.
Let me change a little bit the question. Maybe in the analysis phase, you could also suggest that the other subclasses could also be transformed into a derivation.
Okay, yes, we could do that. But this is just the part that we didn't analyze yet. That would be the first step here, identifying the opportunity. And I haven't worked nothing about this.
Thank you.